Hello and welcome, I'm Ben from Digi Technical Support. In this video I'm going to show you how to send location data from a Digi router through to a remote server. You can see here I have an IX30 router running firmware version 24.12.153.120. The location service is enabled and a GNSS antenna is connected. Let's have a look at the current position information. We go into status and then location. We can see here that the state is enabled. We've got position information and also we've got the number of satellites and the accuracy information at the bottom. Just be aware that for HDOP, which is the accuracy, the lower the value the better. Let's move on to the configuration now. We go into System, Device Configuration, then into Services, Location. The location service is enabled and the update interval is every 10 seconds. This means that although a constant stream of location data is coming into the router, the actual information data shown to the user will only be updated every 10 seconds. If we expand location sources, you can see here that the location data is coming from a built-in GNSS receiver that's built into the modem. To send this location data through to a remote server, you need to go into Destination Servers and add a new server. So we click on the plus. We can give this a label and add in a destination IP address. And this is going to be the IP address of the server that's listening out for incoming location data. The destination port is the port number that the remote server is listening on. The protocol can be TCP or UDP. This defaults to UDP as that is normal for this type of function. The forward interval multiplier is set to 1, and this means to send data to the remote server every 10 seconds, as configured further up in the location update interval. If, for example, you wanted location data to be sent every 3 updates, so every 30 seconds, you could change this to 3. So now if you look at the location status information on the web interface, that will update every 10 seconds, but the location data sent to the remote server will be sent every 30 seconds. We're going to leave this set to 1. The outgoing message type can either be set to TAIP or NMEA. I'm going to set this to NMEA. The talker ID sends information to the remote server about the source of this location data. If you leave this set as default, then the correct information type will be sent across to the remote server. The next option down for behavior when fix is invalid, from here you can choose to send an empty string, send nothing, or send the last known fix. I'm just going to leave this to send an empty string. There's sometimes a requirement to prepend or append text to the information string that's sent across to the remote server. So for example, you could type in here ix30-lab- and what will happen now is every location string will have that text prepended. Scrolling down a bit further, we have some filters. Expanding the filters shows the information that's going to be sent to the remote server. If you would like to trim these down and remove some of the options, you need to go into the 3 dots and select delete. If you're only interested in the GGA, GLL and RMC, you can come in here and remove the rest. That's the configuration complete. We can now click on Apply. The location data is now being sent to the remote server. To verify this is working, we can check the data being sent and the data being received. First of all, let's check the data is being sent. So I'm going to bring up a terminal session. I'm going to log in using SSH and go to the shell. From here, I can run a TCP dump command. So I'm going to say TCP dump. Interface can be any. I'm going to look for ASCII text, and then we're going to say port is 2222. -n means don't resolve DNS. So if we run that, in a moment, we should hopefully see some GNSS data coming through. So there we go. We can see there that a packet's been sent from 172.17.0.30, which is the router IP address, through to 192.168.0.10, port 2222, which is the laptop that's listening. You can see there that we also configured the text to prepend to the location data. So it says ix30-lab- and then it comes up with the 3 strings that we configured, the GGA, the GLL and the RMC. And they're going to appear every 10 seconds, and you can see that in the timestamp on the left hand side. That's proving that the data is being sent. Let's have a look now at the data being received. If I bring up a command prompt, on here I'm going to run the netcat command, tell it to listen for UDP on port 2222. We have got the prepended text, ix30-lab, and then we've got the same 3 strings coming through, the GGA, the GLL, and the RMC, proving that the data has been sent and received at the remote server. And that concludes this demo. For more information on this or any other feature of your Digi router, please see the support pages at digi.com/support.